convergent?
Because it's the crazy.
Okay, so let's check it out.
But it can be up to minus infinity.
Okay, so let's check it out. So what we need to do is stick in different values of n. Now, by definition, the values of n that we stick in are going to be positive integers. So 1, 2, 3, 4, 5. You happy? Because it doesn't make sense to be putting in negative values in here. Like I wouldn't ever be looking for the negative third value in my sequence. That doesn't make sense. But the third value in my sequence absolutely does. Okay? So let's check it out. Let's just write this sequence in. So what would the first term be? 1/3. Okay? What would the first term be? Let's start with the first term. What would the first term be? Just 1, yeah? What would the second term be?
1/2.
What would the third term be? 1/3. What would the fourth term be? What would the fifth term be? And then sixth, and then 1/7. Do you get the idea? Okay. So what I would do is if you're ever not sure whether a sequence is convergent, divergent, or periodic, just start off by writing what the sequence looks like, and then hopefully you'll get the idea. Okay. So in this case, what's happening? Is it convergent, divergent, or periodic? It's convergent. You happy? Because it converges to what? 0. Yeah, good. And if you check out on here, let's try 1/n. Stick that in. Okay. Are you happy that as I consider more and more terms in my sequence, it converges to 0? And you can see that through that straight line, that line there. Is that okay? Converges to 0. Yeah? Any questions about that? Yeah? Okay. What about something like this then? So what about a sequence that looks like this? What do we reckon? Periodic? Why do we think that? Yeah, good. So if you just start sticking values in, -1 to the power of 1 is just -1. -1 squared is +1, because -1 times -1 is +1. And then we go -1, and then 1, and then -1. Just by sticking in different values of n, can you see what's happening here? Right, let me put my 3 dots on the end to show it carries on forever. Okay. So you're happy this thing just goes up, down, up, down, up, down. It's just flicking between the two. It's repeating. Therefore, it must be periodic. Is that okay? And in fact, let me just show you this here. Equals -1 to the power of n. Okay, you happy with that? So as you consider more and more terms in your sequence, so start from 1, 2, 3. You're happy it just flicks between the two. So +1, -1, +1, -1. Okay, any dramas? Anything wrong with that? No? Okay. All right then, a little bit harder then. Let's see what happens with this. So let's try n squared over n cubed plus 1. What's going to happen here, do you think? Convergent. Why do we think that?
It's decreasing.
So you tried different values of this, yeah? Okay, so what would the first term be? 1/2. What's the next one? 4/9. What's the next term going to be? 28, okay. So are you happy that these are getting smaller? What's the next one going to be, just to make sure? 65, aren't we? Because 4 cubed is 64, add 1, you get your 65, okay? So in actual fact, what's happening here is we're getting smaller and smaller numbers. Now, are you happy that this one is slightly trickier? Yeah, you happy this one's slightly trickier? So what we need then is an alternative. We need to be able to utilize these ideas, and then we come up with an alternative method to find out what's happening here, because sometimes it's not always clear. Like, I'm not terribly good with my fractions. It's not necessarily clear whether they're getting smaller or bigger. It's not necessarily clear what's happening here. So what we're going to do is this idea of a limit test. Okay. Now, who in here has met the idea of a limit before? I think we all have, because we've looked at calculus. Okay. So who can remember what a limit is? What is a limit?
Boundary.
I think a good word for this is approaching, okay? A limit will tell you the value which something approaches, all right? So for example, the limit of this sequence here would be what? 0, wouldn't it? Because we're getting smaller and smaller and smaller. We're approaching 0. Okay, so I could say that the limit as n approaches infinity, in other words, as I consider more and more terms in my sequence, of this thing here, 1 over n, would be equal to 0. Okay? All right? If I did this thing up here, if I use that notation up here, the limit as n approaches infinity of this thing, 3n, would be equal to, yeah, positive infinity. I'll let you get away with that, okay? Because, yeah, it's getting really, really big in the positive direction, okay? So what about this one? Does this have a limit? So what would the limit as n approaches infinity of negative 1 to the power of n be? Does this have a limit? Well, that's a good point, because I guess it depends where you stop. Like, if you decide to stop here, for example, if you decide to stop your sequence here, you say, right, I'm getting bigger and bigger and bigger. I think that's big enough. Oh, I'm going to stop there, so it's going to be equal to negative 1. Yeah, seems reasonable. But if you carried on going and you decide to stop there, your limit would be 1. Yeah, your limit would be 1. I mean, the way which we kind of work with this is to say, well, why not just take the average of both of those terms? In other words, could the limit be equal to 0? Because the average of negative 1 and 1 is 0. Like, that's slap bang in the middle. It's a bit like negative 1 is the lights off, 1 is the lights on. Like, let's take the average of that. It's kind of neither on or off. Yeah, it's in the middle, right? I mean, it does actually have a limit, and we do tend to say that the limit is equal to 0. But I think a better way in the context of this discussion is that it's undefined. Okay, so let's just say it's undefined in this case. So undefined limit, okay? Because it's periodic. It doesn't really approach anything. It doesn't really approach anything with a sensible meaning, okay? So let's apply the limit test to something like this. So let's go the limit as n approaches infinity. Make sure you get the notation right. This means the limit. What does the value approach as you get bigger and bigger terms? N gets bigger and bigger, n approaches infinity. Of this thing look like? Over n cubed plus 1. Okay? So let's think about this. Let's think about this. Have a look at the denominator. What thing is going to grow faster? The n cubed term or the 1 term? The n cubed term. Are you happy? Because eventually we're going to be sticking like 1,000,000 cubes in there. Plussing 1 to that is not going to make the blindest bit of difference, right? It will be close to whatever 1,000,000 cubed is. Yeah? So we can say that this approaches n squared over n cubed. Would you be happy with that? Okay. And then I guess we can do a little bit of sort of arranging with this. So what's n squared divided by n cubed? Yeah, that's just 1 over n. So now if I ask the question, what happens as this thing gets bigger? Well, it takes on the characteristics of 1 over n. Is that okay? As we consider more and more terms in the sequence, eventually this sequence, n squared over n cubed plus 1, will take on the characteristics of 1 over n. And we know that with 1 over n, that is a convergent sequence because it approaches 0. Is that okay? So this thing would also be convergent. So you see how useful the limit test is. The limit test will tell you the value which a sequence will approach by considering what characteristics does it take on as we consider more and more terms.